Parts. Today we will continue the second part of the Fourier series, okay, which is the half range. Okay. So for half range, we can do the extension based on the question, okay, based on what it wants. We can do the even extension or odd extension. Okay, so for example, this one, when you are given this function, okay, this function ft equals to t from 0 up to 1, okay, 0 up to 1 t. So this is the one in red is the graph for this one. But you are this function is defined in half range. Okay, defined in half range. The one in full range is negative L to L or from 0 to 2L. But this one, this is from 0 up to L only. Okay, this function is defined in the interval from 0 up to L. So we need to do the extension. So either odd or even extension. So we start from the even extension. So if we want to extend this into an even graph, so given this, we will reflect this one through the y-axis to get the one in blue. Okay, so that we have an even function. That means we extend this into an even graph. Okay, this is even extension. After that, we just copy this and paste on the left and on the right. Okay, so this is even extension. So now let's say you are given the same function, okay, this one, the one in red. We want to extend it into odd function. Okay, odd, meaning that you just reflect this through the y-axis and you get somewhere something here. Then you reflect this through the x-axis to get this. So now we have extend this into an odd function. Okay, this is odd extension. Then we copy and paste. Okay, so this is odd extension. Now this is another example. Sketch the even and odd extension for this graph. Okay, this one t squared. We know that t squared is a graph of something like this, t squared. But this t squared, we want only from 0 up to 1. Okay, from 0 up to 1, meaning that we just take this part. Okay. Okay, for even extension, that means we extend this into an even graph. Okay, so we reflect this through the y-axis, then we get the one in blue. Okay, so this is the even extension. Then we copy and paste it on the left and on the right. Okay, so if we want to do the odd extension, okay, meaning that this one will reflect through y-axis to get this. Then this one will reflect once again through the x-axis to get this. Okay, so this is the odd extension. Okay, odd extension. Then only we copy and paste. Okay, any questions? Okay, now try this one. Okay, we sketch for both even and odd extension for each of the functions. Ft equals to 1. This is a constant. Okay, constant means a horizontal line. A horizontal line that passing through 1. In this interval, okay, from 0 up to 1, in this interval, have a horizontal line that passing through 1. We start from the even extension. Okay, we extend this into an even function, meaning that we reflect this through the y-axis. Then again, this another half, and copy paste, copy paste, copy this, paste it here and here. Okay, now you try for the odd extension. Extend it into an odd function, then copy and paste. The another half for this for odd function. Reflect this one through the y-axis, you get y here, then reflect this one through the x-axis, you get this. So copy and paste. Copy this and paste it here. And also here. Okay, this is odd extension. For B, 1 minus t. 1 minus t is a polynomial in first degree. First degree meaning that this is a straight line. Okay, t to the power 1. This is a straight line. So to sketch for a straight line, you just need to get 2 points and connect the 2 points with one straight line. Okay, when t is 0, okay, you treat this one as x, this one as your y. Okay, when x is 0, your y is when your x is 0, your y is 1. So 0, 1. 0, let's say 1 is here. 0, 1, there's 1 point here. When x is 3, your y is -2. -2. So 3, -2, -2, let's say here. So this is the line. Now, find for the even extension. Okay, even extension. Okay, have you done your even and odd extension? Where's your graph? Oh, why you have to find? Okay, this is even extension. Just reflect the line through the y-axis. Okay, another one, odd extension. When you reflect this one, through the y-axis. Okay, suppose you get this, then reflect this one through the x-axis. Okay, when this is reflecting through the x-axis, this point 1 will be -1. Here, this point -2, it will be 2. So you just connect these two, one straight line. Okay, so this is the odd extension. Then copy, paste it here. They are all in parallel. They are all in parallel. This is the odd extension. Okay, for C, cos t. This is cos t, but we want only the graph in this interval 0 to pi. It's 0 to pi, that's mean this one. Okay, this one 0 to pi. Try to do the even and also the odd extension. For even extension, we just reflect this through the y-axis. and you get this, then you copy, paste. And the one for even extension, suppose we get something like this. After you reflect this one through the y-axis, and this part you need to reflect through the x-axis. So if this is 1, okay, this point, after reflection, it will be here. Okay, and this point, after reflection, it will be here. Okay, so if you just look at this part, okay, this part, when you reflect through the x-axis, it will be this. Okay, this part reflect through the x, it will be this. This one reflect through the x, it will be this. Okay, that means these two are the same curve. Okay, same curve. Ignore the one dotted curve. So you just copy this and paste it. This is the odd extension. Okay. Any questions? Or d 2t minus t squared. If you want to sketch for this quadratic graph, okay, what do you think is the shape of this graph? Is a prime face or a smiley face? Right. That's first. Huh? A sad thing. That's all. Okay, t squared in front of t squared, when you have negative, that's mean prime base. Okay, if this is a positive, that's mean this one. Okay, so now we know that this curve will be something like this. So we want to find what the x-intercept. Okay, we want to know when is the graph passing through the t-axis. So this 2t minus t squared, we will do the factorization. Factorize the t, we have 2 minus t. Okay. Or we let this function, we let the y, this is the y, equals to 0. Factorize the t. Because when we want to find for the x-intercept, we will let y equals to 0. Okay. Then your t will be 0 and also 2. Okay. That means the graph it will passing through 0 and 2 with this curve. So what is the height of the maximum point of this curve? Okay, you can use the completing the square. Okay, you can complete the square. This one negative t squared plus 2t. Okay, factorize the negative so that you have t squared minus 2t. Then complete the square. T squared, you have t minus 2, you have minus 1. Then minus the square of 1, which is 1. Okay, when you expand, you have this plus 1. Meaning that the maximum point is plus 1. This is plus 1. Okay, so even extension, you just reflect it through the through the y axis. And for the odd, y, then x. So for even extension, get this and copy paste. And for the odd extension, after you reflect through the y-axis, then reflect it through the x. Then copy paste. And ignore the dotted curve. Okay, so this is odd extension. Okay, any questions? Next, we recall the area under the graph. Okay, now let's say this one, this is your GT, okay, function G in T. Okay, this graph is even because this curve is symmetrical about the y-axis. Okay, this is even. And for this graph, this GT, okay, this GT is odd, okay, because this is symmetrical about the origin. Okay, now, for the area under the graph, okay, we can use the integration to get the area under the graph. Okay, integration. So to get the area under the graph of this, we can integrate from negative a up to a. Okay, and we're integrating the GT function. Then you will get the area under the graph. Okay, and the area under the graph on the left and on the right, basically they are the same because this graph is symmetrical. Okay, the one on the left and the one on the right, the figure, the area is the same. And the sign is the same because they are above the x-axis. And for this graph, this area is the same with this area. It's just that the sign for the one above x-axis is plus, the one under the x-axis is minus. Okay, for the area under the graph. So when we are integrating from negative a up to a for this GT, basically we can instead of writing in this way, we can just integrate from 0 up to a. We just get this area under the graph, then multiplies 2. Okay, we multiplies this area under the graph by 2. So we will get the same area under the graph. Okay, no matter you are integrating from negative a up to a or 0 up to a. Okay, we get the same answer. But for the case of this GT, if you are integrating from negative a up to a, for this GT, you will get 0 because let's say this area is -5, this area is +5. When you sum up these two, you get 0. Okay, so if the function is odd and you are integrating from negative a up to a, you get 0. Okay, this is the fact. This is the fact. Now, what will happen when your FT is even? Okay, if your FT is even, okay, this is the one in black is the formula for the full range Fourier series. Okay, the one in black is the formula for the full range Fourier series. Now we want to look at what's happened when your FT is even. Okay, we start from A0. If this function is even, we are integrating from negative L up to L. So we can write this in this form. Okay, 0 up to L, but we multiply it's 2. Okay, we multiply the 2 because FT is even. Then this is the new formula. Okay, up to this, are you able to understand why we get this new formula? Okay, because the function is even. Okay, now this is a product function, ft times cos. We know that cos is an even function. Okay, cos is an even function. Now ft is even now. Okay, ft is even now. So even, we get an even function. Meaning that this product function is even. When this is even, we can change this into this. Okay, now ft is still even, okay, even, but your sine function is odd. Sine is odd. So even odd, you get an odd function. That means this product function is odd. When this is odd, this integration, it gives 0. Okay. So when your Bn is 0, okay, Bn is 0, that means this term is gone. So you have only An cos n pi t over L. Okay, and also A0 over 2. Okay, this is the new formula now. So this one, the one in orange color, this is called Fourier cosine series. Okay, why it is called as Fourier cosine? Because in this series, you have only cos function. Okay, you have only cos function. So this is Fourier cosine series. Okay, so in short, if your function, okay, if the function given, the periodic function is even, then what you want to find is Fourier cosine series. Okay, if your function is even. And you will use this set of formula to get this Fourier cosine series. But of course, if you want to use this full range Fourier series to get for the answer, okay, no problem. You will get the same answer. Okay, you will get the same answer. But when you compute for Bn, at the end, your Bn is 0. Okay, that's it. Okay, so this is the new formula. Okay, and it is called a Fourier cosine series, where we just need to find for A0 and An. Okay, another one. Okay, another case when your ft is odd. So when your ft is odd, your A0, it will be 0. Okay, ft is odd, cos is even, so odd even, you get odd function. So this is odd function. When this is odd function, you get 0. Okay, f is odd, sine is odd, odd, we get even. So this is even function. So this integration can be changed into this. Okay, so this is another set of formula where A0, An are both 0. When A0 0, this term is gone. When An 0, this term is gone. So we have only Bn sine and pi t over L. So this is called as Fourier sine series because in this series, we have only sine function. Okay, so these are the difference between Fourier cosine and Fourier sine series. The one cosine is what? Ft even. When ft is even, we find for the Fourier cosine series. When ft is odd, we find for the Fourier sine series. Okay, so this is the formula. Okay, we just need to find for the Bn. Okay, Fourier sine series when your ft is odd. Okay, so this is the summary. Okay, this one and this one is the one for full range. Meaning that if your FT is neither odd nor even, when your FT is neither odd nor even, you have to use full range Fourier series to get the Fourier series. But if your FT is even, you can use this new set of formula, okay, to get the Fourier cosine series. Okay, but of course you can also use the one from full range Fourier series. You can also use this set of formula. Okay, you will get the same answer. Okay, but since we know FT is even, okay, Bn is confirmed 0. Okay, if FT is even. If your FT is odd, A will be 0. Okay, this is the summary. Okay, so this is the formula for Fourier cosine series. And now we look at the example. Sketch the graph of the even extension. So you are given a function that defined in the interval of 0 up to L. Okay, 0 up to L. So this is similar to the last exercise. Okay, the exercise just now. Okay, if you expand, you will see a quadratic function. Okay, this one, a quadratic function. So when you sketch, you get this. Since what it wants is an even extension, so you just reflect this one through the y, then you get this. Then copy and paste. So this is the even extension graph. Then find for its Fourier cosine series. Okay, for even extension, when your FT is even, this is your FT now. Your FT is even function, the one defined in full range. This is the one defined in half range. 0 up to L. But after you do the extension, this is in a full range. Okay, full range FT. So if your FT in full range is even function, then your Bn will be 0. Okay, we just need to find for A naught and An. Okay, so L is pi. Okay, this one 0 up to L. So L is pi. So you just substitute L is pi into the formula. This is the formula for A naught. We use the Fourier cosine series formula. Okay, substitute the L by pi. And since we have only one function, okay, with one interval, so this one we do not need to break this into two. Okay, just one integration. So integrate as usual, then substitute the values, you get this pi squared over 3. We just integrate as usual, okay, you will get this A naught. Okay, and this is the formula for An. Okay, since your L is pi, substitute L by pi. Okay, when this L is pi, cancel out the pi. Okay, cancel out the pi, you get nt, cos nt. Okay, and your ft is this function. So to integrate this, we use tabular method. Okay, tabular method. Then you will get this line. Okay, then substitute pi and 0 into the function, you will get your An. Okay, so if you know how to get the full range Fourier series, suppose this one shouldn't be a problem because the steps are the same. Okay, the steps are the same. It's just that the formula is slightly different. Okay. Then after that, you just substitute your A naught and An into the Fourier cosine series formula to get the final answer. Okay. Okay, now we try this exercise. Okay, we try this exercise. Okay, sketch the graph of the even extension. Even extension. Wants only even extension. And after that, find for the Fourier cosine series. Okay, in the appendix of your final exam, you will be given the formula of the full range and also half range, both the cosine and sine series. Okay, so 3 sets of formula will be given. So you will need to choose the correct formula, okay, based on the FT, okay, based on your FT. Okay, from 0 up to 1, you have T. Zero up to 1, you have T. Now we want even extension to reflect the line through the y-axis, extend it into an odd function, even function. So even function. Okay, so what is your L? L is 1. Substitute 1 into the formula. Your FT is T. Cancel out the 2. The T squared from 0 up to 1 is 1. Okay. Then A naught. Okay, this one. When your L is 1, okay, when L is 1, you have N times T. Okay, T cos n pi t. You have to integrate using
tabular method.
tabular method. Integrate cos sine and sine t over and phi. Okay, over and phi. Differentiate this one, respect t, you get phi. Then integrate once again, negative cos n phi t over n squared phi squared. Continue here. You have two t over n phi sine and phi t Okay, try to substitute the 1 into the t. Okay, now 1 if to this t, we have sine and t. What is sine and t? Sine and sine and t, sine and pi. When t is 1, sine and pi is 0. Okay, plus 1 into this t, cos and pi. Okay, cos and pi is not 0. Cos and pi. Okay, minus 0 into this t and also this t, 0. 0 into this t, cos 0 is 1. Cos 0 is 1. Okay. From these two terms, you can factorize the 1 over n squared pi squared. Okay, then you have cos n pi minus 1. Cos n pi is this 1 minus 1. Okay, so this is your an. So the Fourier cosine series is okay, just now your A naught is 1. Just substitute your an into the formula to get for the final answer. Okay, L is 1. Okay, actually, Fourier series is very simple to be solved because it just involves the integration. And the integration normally is either direct integration or tabular method. Okay, actually, it's very simple, quite simple to be solved. Okay, you just need to identify the FT is either odd or even or neither both, then you know which one to choose. Okay, which formula to choose. Any questions for number 1? Okay, for number 2, both of these two are straight lines. Straight lines. Okay, 0 up to 1. This one is simple. 0 up to 1 is t. And 2 minus t is also a straight line. Okay. This is also a straight line. You just need to find for the 2 endpoints, okay, for this interval. When x is 1, what is your y? When x is 1, treat this as 1. Treat this as x. This is your y. When x is 1, what is your y? 1. So 1, 1, 1. When x is 2, your y is 0. So 2, 0. 2, 0 is here. So you just join the 2 dots with 1 line. Okay, so this is the function defined in half range. Okay, this is the function defined in half range. And now we want to do the even extension. Okay, even extension. So you just reflect the 2 lines through the y-axis. Then copy, paste. Okay, what is L for this question number 2? What is your L?
L 2.
L is 2. L is 2. This function, we know that this function is defined in half range. Why we know that this function is defined in half range? Because only the function which is defined in half range can be doing for this extension. The one in full range, we don't need to do any extension. Okay? If you're asked to do the extension, that means the function is defined in half. Okay, so up to 2, that means L is 2. So for this integration, we need to break this into 2, because from 0 up to 2, you have 2 different functions. Okay, you have 2 different functions, so we have to break this into 2. What is your A naught? A naught? Your A naught should be 1. Four minus 2, 0. Plus half. Plus half. Plus half. That means 1. Half plus half, 1. Okay, next, find for a n. Okay, and the integration here, L is 2. Okay, so this is your angle for the cos function. And this integration, you need to break it into 2. Solve this. Both integrations, you need to apply tabular method. Tabular method. Okay, integrate cost, we get the sine function n times t over 2 divided by n pi over 2. The over 2, you can bring it up. You can bring it up directly. N pi over 2. The over 2, I bring it up. Okay, integrate once again, you get negative cos n pi t over 2. So you have n squared pi squared, 2 times 2, 4. And now we look at the substitution of 1 into t. Okay, when this 1 substitute into this t, you have sine n pi over 2. Sine n pi over 2 is not 0. Okay, and this t is 1. When t is 1, you have 2 over n pi sine n pi over 2. Okay, just leave it in this form. Okay, then when t is 1, you have n pi over 2, cos n pi over 2. Okay. And minus 0 into this t, and also this t. You get 0. Then 0 into this t, cos 0 is 1. So you have this plus 4 over n squared pi squared. Okay, the next line, 2 into t. Okay, 2 minus 2, 0. This means this term is gone. 0. Okay, when t is 2, okay, when t is 2, cancel out the 2 with this 2, you have cos n pi. Okay, cos n pi. Then 1 into the t, and also this t. Okay, so when t is 1, you have 1 times 2, which is 2 over n pi sine n pi over 2, when this t is 1. Okay, and same goes to this one when t is 1. Okay, that's simplified. Cancel out the 2 over n pi sine n pi over 2. And this is the same with this. Minus, minus, we have plus. So 4 plus 4, we have 8. For this 2. Then we have this one and this one. Factorize 4 over n squared pi squared. So this is your A. And substitute your A naught and AN into the Fourier cosine series formula. Okay, the A naught, this naught is 1. Okay, any questions? Okay. And next we look at the Fourier sine series. Okay, for Fourier sine series, we just need to find for Bn. Okay, Bn because A is 0 for Fourier sine series. Okay, so this is the same function. Okay, the same function as the example just now. Okay, so we have this curve. So if we want to have the odd extension, so we will reflect this through the y-axis, then through the x-axis to get this part, okay, the other half. So this is one full cycle. So just copy and paste. Okay, paste. Okay. Next, Okay, if we look at this one, your L is pi. Okay, your L is pi. So substitute pi into all L, okay, in the formula. Okay. So this is the formula for Bn after you substitute L by pi. Okay, this one. When L is pi, you can cancel out the pi. So you have nt, sine nt. Okay, sine nt. And your ft is this function. So this one, polynomial with sine function, we have to use tabular method. Okay, tabular method. So you see the working is same exactly as you find for an. Okay, so substitute pi and 0, you get this Bn. Then just substitute the Bn into the formula of the Fourier sine series. Then you will get the final answer. Okay, so for Fourier sine series, okay, when the function is odd, you just need to find for Bn, but use the correct formula. Okay. Okay, this is the summary of the Fourier expansion. So there are two situations. Okay, there are two situations that you need to take note. Okay, if you are given a periodic function with period of 2L, where it is defined in full range, either negative L to L or 0 to 2L. Okay, if you are given a full range, okay, full range periodic function, then we will look at whether the ft is odd or even. If the ft is odd, then it will be expanded into half-range Fourier series. Okay, half-range sine, Fourier sine series. That means if you are given the full range periodic function, and if you use the formula of the full range Fourier series, but if ft is odd, that means what you get at the end, it will be Fourier sine series. Okay, same goes for ft. It's even. You will get Fourier cosine series. But for this case, when ft is odd, meaning that your a must be 0. A not an must be 0. If your ft is even, that means your bn will be 0. Okay, if you use the formula of the full range Fourier series. Okay, so if ft is neither odd nor even, it will be expanded into full range Fourier series. Okay. And in another situation, if you are given a function which is defined half the range, okay, in half the range, 0 to L or from negative L to 0, normally it will be 0 to L, okay, instead of this one. Okay. Then it can be expanded into Fourier sine series with period of 2L or Fourier cosine series, okay, with a period of 2L. Okay, so it depends. It depends on the function given. If the function is given in full range, okay, you can use the full range Fourier series to get this. Okay, but for these two cases, we have foresee that which an or bn is 0. But if you are given the half range function, then you will do the this is odd extension and even extension. Okay, so it depends on what is the formula given. Okay, this one I will continue in the next class. Okay, because for section 1 we stop here. Okay, so I will continue this one. Okay, and in the next class on Thursday.